Good morning, everyone. Today, we are going to look into the workshop on blockchain and AI. It is a very wide topic, right? But I've tried to make it as crisp as possible to have some takeaways within this 45 minutes. Okay. So, hi, everyone. I'm Purnima. I'm assistant professor at the Singapore Institute of Technology. So I've been here in this university for 5 years now. Yeah, I've been working on blockchain for quite some time. And I have a couple of projects with several government agencies in Singapore on blockchain. Yep. Okay, so just a quick intro slide. So we have a blockchain applied computing FinTech degree in Singapore Institute of Technology. So for the students here, so if you're planning to further your career in FinTech, so this is one of the options you can pursue. So you can go to Singapore Institute of Technology website and you can browse the degree program here, right? And that's our students who won the recent hackathon, right? Okay. So to make this session a bit more interactive, so I've created a Slido session for you all to join in. Okay, you can scan the QR code here. And hopefully we can have a more interactive session. Yeah. Okay. Got it. Yeah. The QR code will be there in the next slide as well. So some of you can still scan here. So that's a table of contents for today. So first we will go through a brief overview, a history of what is a fintech ecosystem, right? Before we jump into the technologies itself. Then we'll look into blockchain and fintech. So we'll spend about 15 minutes there. And then we'll jump into smart contracts. Okay, what are smart contracts and what are cryptocurrencies? How are the tokens used within the smart contract? What are oracles? Okay. And then we will dive a little bit more deeper on how AI integrates with blockchain to enable fintech applications. All right. So if you haven't joined yet on Slido, you can join in here and you can type in your questions or expectations of this workshop. Yeah. So what do you expect from this workshop? We saw a brief overview, but if you have any specific expectations, feel free to put it on the Slido, and I'm happy to answer any questions. Okay. All right. So let's dive in to a quick introduction to the fintech ecosystem, right? So what is a fintech ecosystem essentially, right? It comprises of course, you will have the government that plays a major role, right? They set the regulations. We have MAS setting the regulations of how to use the various technologies into new fintech advancements. And then we have traditional finance institutions, such as the banks and the payment applications. And then we have the customers, of course. Without the customers, there is no ecosystem. And most importantly, we have the technology developers that enable new fintech startups that you see across the expo today, right? So the innovation, without innovation, there is no economic growth. I think that's why one of the primary reasons in Singapore we are hosting this SFF across all Southeast Asia is because we have a lot of fintech startups and advancements in terms of technologies, cutting-edge technologies. And we are going to look into blockchain and AI and how they integrate together in today's workshop. Okay. And MAS, as a regulatory body, sets up the regulatory framework for these fintech startups to work with. And this also helps mitigate any risks, right? And then, of course, for market expansion, we need to have a competitive advantage through such innovative technologies, right? Okay, that's a quick overview of the fintech ecosystem. I believe all of us have some background, given our interest in today's workshop. And for the R&D part, it's a continuously evolving part, and we need to keep track onto what is the recent technologies. And I believe that's why we are here today, to look into blockchain and AI. Right? So a quick introduction. to FinTech was done. And now we will dive deeper, spend more time on the blockchain technology. So what and why blockchain, right? So primarily, we all know blockchain is a decentralized technology, which means there is no central authority. Okay, so if I want to sell something to another person, I don't have to go through a intermediary platform, right? So I don't have to go through Lazada, or I don't have to go through Carousel, for example, right? So I can directly transact with you in a secure, transparent, and an immutable way. Okay, so that's what is blockchain technology that enables secure, transparent, and immutable transactions. Okay, and one more point, it is tamper evident. It is tamper evident. Okay, so there might be some misconception sometimes because earlier blockchain technology was termed as tamper proof, right? But now actually with the advancements in quantum technologies and so on, we have to term it and reword the key point here as tamper evident, which means if something happens on the blockchain record, it becomes evident. You can detect it within seconds, right? So how blockchain is adopted into various businesses is payment infrastructure, of course. Just now we discussed the example of direct transactions, right? And then supply chain finance, trade finance, investment management, and digital identity management. So we have been doing digital identity management in Singapore and also across the world for quite some time. I see some of the students here. Have you used open certs? Do you know what are open certs? No? Okay, when you graduate, you have your degree certificate, right? So this degree certificate will be used for subsequent jobs and even also when you have to apply for higher studies and so on, right? So these degree certificates are added to the blockchain, okay, with your unique identity. So if the university or the job employer wants to verify your degree, they can verify your degree on the blockchain, Ethereum blockchain, through the open certs, right? So in the future, when you apply for degrees and also for job, you can upload your open certs to the job application, right? So another thing is digital identity management. We have been doing in Singapore for quite some time, especially during the COVID. We all had our health certs. You remember, like when we leave Singapore, the immigration, we use the health certs that you're vaccinated. How did it happen? It was a QR code, yes. But what was behind the QR code was Ethereum blockchain, right? So that's why you were able to add your record securely and verify it securely in a fast and efficient way at the immigrations in Changi Airport, right? So these are some examples that we have been doing this for quite some time. So it's not just in theory, it's been in practice for more than 5 years. So to summarize what we have discussed, so blockchain is a distributed ledger technology with no central authority. No central authority. There is no central bank. There is no central e-commerce application, right? So it is decentralized. I can directly transact with the seller or the buyer, right? And then how is it enabled? Because of the characteristics of blockchain. One is the distributed ledger technology through peer-to-peer transactions. And then we have the security through the cryptographic hash functions. Okay? So through the blockchain cryptography, we get a secure end-to-end transaction. And then it is an append-only sequential chain. So when you say blockchain, it's a sequential chain. You can keep adding to the blockchain, but you cannot delete the record. So if you want to rewrite a record, then you will have a new record added to the block to override the previous timestamp, right? So you cannot delete any record of the blockchain. That's an important property. And then there is something called distributed consensus. So if you have to add a new record to the blockchain, it has to go through a consensus mechanism. So I cannot directly go and add the record to the blockchain. I have to get a set of group of validators. We call validators or miners in different contexts. So they have to agree upon, each node will run an algorithm, and the algorithm has to agree upon the record before adding it to the blockchain, right? So this is distributed consensus. So you can see that because of DLT and P2P, we have no single point of failure, right? So because, for example, in Google, Amazon, so you have a Google server, you have an Amazon server. So if the server goes down, then you have to go to another server because that server is down already, right? All your records on that server is down already. But you have an alternate server to go through, a backup server, right? But all your record is on the same server. So if you have a record A, the whole entire record A is on server A. With blockchain, it is decentralized, which means your record A is divided into A1, A2, A3, A4, A5, and is stored across different servers, not the same server. So if someone hacks into the server, they get only a fragment of your data, not your whole data. So they cannot make sense out of it. So it is more secure in that fashion. Okay? And immutable data storage because it's a append-only sequential chain. You cannot delete or you cannot change any record. And finally, the applications are protected across different attacks because of the distributed consensus protocol. Okay? So it does solve the important problem of trust. Okay? Okay. Right. So we saw it is distributed, it is decentralized. So what is the difference between distributed and decentralized? Right? So there are online service providers, Google, Amazon, eBay, Apple, Lazada, so many applications. So are they distributed? The way they host the application, is it distributed? Okay, that's two different terms, distributed, decentralized. So we are looking at the question of, are they distributed? So for example, server 1 goes down. Do I have another server 2? Okay, we'll see there are 6 responses. Let's see. There's a slight, okay, the majority is yes, which is right. Okay, because if server 1 goes down, you're trying to access your Gmail, for example. So server 1 is down because of some power failure. Then your email is accessed through another server B, backup server, right? So which means it is distributed. You have a server in Singapore, you have a server in Malaysia, you have a server in Indonesia, you have a server in US, right? So if one of the servers goes down, you can get the data from the backup server. So it is distributed, right? Next question, is it decentralized? Are these services decentralized? Yeah? So we have about 11 responses. Let's see. No. You're right. So it is not decentralized. I hope you just didn't answer no because the previous answer was yes, right? So the answer here is no because your data is not, the whole data is not stored in a single server, right? We just saw it is stored across different nodes across the world, right? So this is why we need blockchain, because there is no single point of failure and there is no single point of attack. So if any one server is attacked, then not all your data is lost. Basically, none of your data is lost because only a fragment of it is being exposed and the attacker cannot make sense out of it, right? So that's why blockchain is important. That's why we say blockchain is secure and trust, enables trust, okay? One more question. How best would you describe blockchain? How best would you describe blockchain? To keep up with the time, I've enabled a timer from this question onwards. Okay, we have about 8 responses. Okay, decentralized and distributed ledger. So that was our 2 previous questions, right? So blockchain is both distributed and decentralized, right? So you can figure out the term DLT, right? Distributed ledger technology. So blockchain is also known as distributed ledger technology that enables security through peer-to-peer consensus. Peer-to-peer as in P2P consensus. Those are the common terms that you hear for blockchain, right? We will dig out each and every term and understand them better. Okay, so now with this understanding, let's get a bit more deeper to understand what exactly, let's decompose it a bit more to understand better on the blockchain. So imagine a book, okay? A book has so many pages in a sequential order. So you have page number 12, page number 13, right? Page number 13 comes after page number 12. It cannot come before in a book, right? Similarly, in a blockchain, it's a sequential chain. So you can think of each page in a book as each block. And they are connected sequentially through the page numbers. So what are page numbers in a blockchain? They are also known as hash. More specifically, they are known as previous block hash. Okay? So each block, for example, block 2 has a previous hash of the block 1. Okay? And block 3 stores the hash of block 2. What is this hash? The hash is a signature of a block. For example, the hash of block 1, okay, is unique. The hash of block 1 is unique. You can think of it as a signature. So if any small change happens on block 1, the signature of block 1 will change. And this signature will not match with the signature stored, the previous hash stored in block 2. So we can easily figure out that someone has manipulated the data on the block. So that's why blockchain is known as tamper-evident record, right? So if this hash has been, if this block has been manipulated with, then block 2 hash will also change, which means the signature of block 2 will change, and that will affect block 3. Signature of block 3 will change, and that will affect block 4. So one small change in one block will be across all the blocks, will be reflected across all the blocks. So one small change will have a very big outcome or impact, right? So that's why it's very easy to determine why or when the block was manipulated with, if it has been. It is very difficult to alter any record on the blockchain, but even if it has been done through quantum technologies, for example, quantum computers are very fast. So if they are, even if they are able to change the record, then that is very easily detected on the blockchain, right? So you can see, similar to the book pages, right? If you remove page number 13, it's very visible, and it can be detected easily, right? So anyone tampers with a specific record, it becomes evident in all the following blocks in a blockchain, to summarize this slide. Okay, so each page refers to a block. It's connected to the previous page, right? And it is easy to detect any change on the block, and it is identified through the previous block hash, right? So while it is impossible to tamper with the record, with recent technologies, it may be possible. We cannot ignore the fact it may be possible, but blockchain is still tamper evident in that case. Okay, so that's why it finds various applications in the fintech domain. Okay, so to summarize all our understanding and discussion, so blockchain is a peer-to-peer distributed ledger, which is cryptographically secure. It's append only, and it is updatable only via consensus. Some of the consensus protocol are proof of work, proof of stake, POS, POW, for example, if you've heard about it, right? So there is no central authority. There is no central authority in this case, right? So those are the advantages also of the blockchain technology. Okay? Any questions so far? Okay? Okay. Right. So I have some more questions. Then I have some questions for you. Okay? So you can get ready. I think there are 3 questions following this. So which of the following best describes the architecture of blockchain? right? So it's a distributed peer-to-peer network. It's a distributed system with no central authority, right? So no central authority, okay? Next question. What is the objective of a hash function in the blockchain? It's secure against malicious changes, right? So the cryptocurrency transfer is basically done through, it's known as a transaction on the blockchain. It happens through consensus algorithms. And the transparency of the blockchain is enabled through the verifiable property of blockchain, okay? So the hash function here is used to secure against any malicious changes, right? Is blockchain same as cryptocurrency? That's a $1 million question. Is blockchain same as cryptocurrency? No. Yes. So as majority of you have highlighted here, I think you all get to understand that the blockchain technology is different from cryptocurrency, right? So these two are not the same. Then why are they not the same? Why are they not the same? You see here, whatever is shown here, so the Bitcoin, Ethereum, Tether, USDC, all these are the cryptocurrency, right? So USDC is a stable coin. It is still a cryptocurrency. Now in Singapore, we also have XSGD, which is a cryptocurrency pegged to the Singapore dollar. USDC is a stable coin. It's a cryptocurrency pegged to the US dollar, right? So we also have the stable coin now in Singapore, XSGD, right? So all these are cryptocurrencies, and they are used to make payments. The cryptocurrencies are used to make payments. They are associated with some form of a fiat currency, right? Blockchain, on the other hand, is a network. It's a chain. It's an append-only sequential chain where all the transactions are recorded securely, right? So blockchain doesn't have any monetary value, and it cannot be transferred as well, okay? Whereas on the other hand, cryptocurrency is something that makes use of the blockchain to perform any blockchain transactions. So it's while blockchain is a decentralized ledger, it's a DLT with peer-to-peer network. Cryptocurrency is used to store the value, the monetary value on the blockchain, right? So some of the, we generally call it as tokens. Some of the tokens do have monetary value, while some don't have, yeah? So if you know about NFTs, NFTs are tokens that don't have monetary values, but it will eventually have a value upon distribution, right? It is associated with the asset. Whereas the tokens, on the other hand, are having a monetary value within themselves, right? They have a value within themselves. So it's great that we understand blockchain is not equal to cryptocurrency. So this has been a misconception for quite some time because we always associate blockchains with bitcoins, right? Bitcoin is a cryptocurrency. Bitcoin network is a blockchain, right? So what is a blockchain transaction? We have been talking about blockchain transaction, cryptocurrency, but what is exactly a blockchain transaction? How does it happen? So firstly, if I'm a seller and someone wants to buy from me, they will go through the blockchain network with no intermediary, right? So the buyer initiates a transaction. Okay, the buyer on the blockchain network initiates a transaction. The transaction represents various actions on the blockchain. For example, in this case, the transaction says A wants to send money to B, and the transaction is represented as a block. Now, this block is sent through across all the verifiers or miners. Okay. Okay, what happened? Okay. So the block is broadcasted to all the parties in the network, and there is a consensus algorithm. So the consensus algorithm approves the transaction, then it is added to the block. And once it's added to the block, the money is transferred, right? So when the transaction is flooded and the consensus happens, there should be at least 3 nodes, okay? Minimum 3 nodes need to validate the transaction, okay? So why 3 nodes? Some consensus algorithm use computation, okay, like the Bitcoin blockchain, which uses computation power. Some consensus algorithm, like the proof of stake, the Ethereum blockchain, uses the stake, amount staked into the network, right? So in all these cases, you need to arrive at a majority. You cannot have a majority with 2 nodes. So that's why you need minimum of 3 nodes to arrive at a majority, right? So only when 3 nodes approve, okay, there is some consensus arrived, and then the block is approved to be added to the blockchain. Okay? So how do we validate a transaction? Again, validating a transaction is through the hash, the signature hash, right? So for Bitcoin, the block has to be confirmed every 6 times. A block is confirmed only when it is validated by 3 nodes 6 times. Totally 18, right? So there are different types of blockchain. What we saw earlier, Bitcoin blockchain, Ethereum blockchain, all these are public blockchains, right? They are public blockchains. Your health certs added to the public blockchain network, your open certs, degree certs added to the public blockchain network so that anyone can verify your record using the hash. Okay? Only if they have your hash, they can verify. Okay? Private blockchain, on the other hand, is a single organization. So I'm an organization. I want my employees to access my own enterprise blockchain. So that is a private blockchain. For example, Hyperledger. IBM Hyperledger is a well-known example for private blockchain. The third one is a federated or consortium blockchain, which is in between private and public blockchain in a way, because let's say there are 3 organizations, a private company, let's say, for example, MAS, and then there's one more entity, let's say a bank, right? Now, these 3 entities need to communicate with each other through the common blockchain record. So then we need to have a federated or a consortium blockchain, okay? So some of the examples are Coda. Even Hyperledger, IBM Hyperledger, can also be used to build a federated blockchain, okay? So what's more important here is the question, again, a very basic question, which is more secure? Is a public blockchain more secure or a private blockchain more secure? Anyone? Anyone? I don't have a Slido question for this. Public blockchain? Yeah, that's right, actually. So public blockchain is more secure. Why? A public blockchain has millions of nodes, okay? And for the millions of nodes to agree upon, okay, and approve a transaction, okay, is more secure compared to a private blockchain, which has only 10 nodes. All right? So how am I saying this? Let's say there are 100 nodes, okay? And I'm an attacker. I want to attack the blockchain consensus algorithm. Then I have to attack 51% of the nodes, which means I have to, for example, I have to attack 51 nodes. All right? Compared to private blockchain, I have 10 nodes. I have to only attack 6 nodes, right? So just imagine when I said public blockchain, million nodes, an attacker has to attack 500,000 nodes, which is not possible, right? So that is why a public blockchain is considered more secure. For a private blockchain, it's very important to have authentication, strong authentication algorithms, which is the endpoint security, which is common for our IT systems, right? So for private blockchain, it's important to secure the endpoints because of the 51% attack, okay? Right. So we were talking about some of the consensus algorithms. So consensus is nothing but a process of attaining an agreement among the participating nodes before adding a record to the blockchain or before adding a new block to the blockchain, right? So some of the consensus algorithms well known is proof of work, proof of stake. There is also other consensus algorithms like delegated proof of stake and proof of authority and so on. But these are most common: Bitcoin, Ethereum, right? So Bitcoin uses proof of work. Previously, Ethereum used proof of work before the merge happened. Current Ethereum, Ethereum 2.0, is using proof of stake algorithm. Okay, along with the well-known or more decentralized applications supporting blockchains such as Solana, Polkadot, Polygon. All these use proof of stake consensus algorithms, right? So why proof of stake? Why not proof of work? Is mainly because of the computation needed to verify a block. I need to spend X amount of energy to run the computation algorithm on a node, right? But moving towards a sustainable world, moving towards energy saving, we are moving from proof of work to proof of stake, which is based on the amount staked into the blockchain. So if I have 10 ethers compared to another person who has 1 ether staked on the Ethereum blockchain, I have more chance of validating a block. I have a higher probability of validating a block and participating in the consensus. Why should I even participate in the consensus? When I participate in the consensus, I can reward. I can get the reward out of the algorithm that I run, right? So these rewards can be in the form of ether or some tokens as well, depending on the blockchain, right? So blockchain has been reshaping the business models because it's secure. None of the technologies are 100% risk-free, right? All technologies have risks. But with blockchain, we have some form of control to some extent, right? So there have been a lot of attacks as well. There have been loss of cryptocurrencies as well. But those are all early stages. Now we are moving a little bit more towards a stabilized environment for blockchain. That's why we are finding a lot of applications, right? So we are able to control risk to some extent. And there is an instant settlement. That's more important. There's an instant settlement of the blockchain, right? No 3 working days, no 5 working days. It's an instant settlement, right? And then, of course, there's the initial CapEx, which is the capital cost. But the OpEx-wise, it is much reduced compared to existing systems, right? And then the transparency of blockchain enables better auditing, especially in supply chain applications. So that's another main reason for reshaping the business models, right? Some more questions for the participants, okay? Okay. What is the name of the first decentralized cryptocurrency that was built on the blockchain network? This should be pretty straightforward. The first cryptocurrency ever. We have about 16 responses. It's Bitcoin, right? Ethereum came at a later stage, but Ethereum has wide applications because it supports smart contracts and dApps. But the first ever cryptocurrency was Bitcoin, right? Bitcoin was primarily used earlier for payments, but because it is based on proof of work, which uses a lot of computation power and energy, we are moving slowly towards proof of stake, or Ethereum and Polygon, Solana, all these kind of blockchain networks. Okay. What is the relationship between the Bitcoin cryptocurrency and the Bitcoin blockchain, for example? We saw blockchain is not same as cryptocurrency, but what is the relationship between them? Yes, Bitcoin basically uses the blockchain technology to enable P2P transfers, right? So which of the following are types of blockchain here? We saw some types of blockchain. Some are more secure, some are less secure, some need additional endpoint security. Okay, yeah. So the two answers are private and consortium blockchain. The third type is a public blockchain, which is the example of Bitcoin, Ethereum, and so on, right? So private blockchain is Hyperledger, Corda. Consortium can also be leveraged on the private blockchain. It's basically, consortium is multiple private entities put together. So consortium can also use IBM Hyperledger or Corda, R3 Corda, right? Okay, considering time, I hope we can cover some hands-on if possible. I know all of you have your mobiles with you. That is enough to do the hands-on. So before we go to the hands-on, what is Ethereum blockchain and what is a smart contract? So Ethereum blockchain, it came after Bitcoin, but Ethereum blockchain is the one that brought in the flexibility and the decentralized application into the practice, which is the most important feature to enable all the dApps currently, right? So the smart contract was also a new feature brought in by Ethereum blockchain earlier, 10 years back, right? And it is more open source framework. So what is a smart contract in simple terms, right? So a smart contract is something that enables automatic actions upon, it's as simple as a program, okay? It's not anything complex. It's as simple as a program with an if-then condition, as simple as that. Why is it very useful? Because there is no need for a trusted intermediary. Okay, it removes the need for a trusted intermediary. So I want to send funds to B, then I can directly go through the smart contract that will hold the value for me until this transaction is successful, right? So when I go through any e-commerce platform, I'm a buyer, there is a seller. So I want to buy the money, I want to buy the item from the seller. So I send the money to the e-commerce platform, and I'm not sure whether I'll get it delivered on time without any damage or not, right? So I have to depend on the e-commerce. I have to depend on the third-party intermediary. Whereas with blockchain, this third party is removed completely, and there is a smart contract, a program that decides upon successful delivery, the transfer is enabled automatically, right? So I don't have to trust any third party here. So let's say I'm using Carousel, for example, to do a $10 transaction. No problem. I can put in $10. I wait for the product to be delivered. Then my $10 will be held by Carousel before transferring to the seller, right? Let's say I have a Rolex watch. Okay, I'm selling that. I want to buy the Rolex watch on Carousel, right? So now Carousel is a big company, but just imagine 10, 15 years back. Will I trust the platform to sell to buy a Rolex watch? Not really, right? Because probably the company's worth 15 years back was 50,000, and then the Rolex watch is, let's say, because it's a second-hand, let's say it's $100,000. So how will I send my $100,000 to a $50,000 worth company? It's not possible, right? What if the third party, I'm not talking about Carousel, okay, but what if the third party runs away with my money, right? So we had to trust a third party intermediary that is removed completely with a smart contract. There is no need to trust a third party intermediary, right? So these are automatically executed, right? So the advantage here is it's a trustless process, it's efficient, there is a transparency, and there is a ease of access, right? So these are some of the advantages of moving towards smart contract, okay? And of course, smart contract transactions happens through the tokens, and there has to be some standards. Without standards, we cannot trust the process. So for Ethereum, there is the ERC standards. Some of the well-known ERC standards are ERC20 for fungible tokens, and your NFTs are based on ERC721, and the recent one is ERC1155 for NFTs. Whereas for fungible tokens, it's ERC20 and ERC777, right? These are the Ethereum tokens. So the smart contract life cycle is basically, you write a smart contract, which is based on a Solidity language, and then it's compiled into a bytecode, and then it is deployed into a contract address before adding it to the blockchain, right? So there is something called a oracle, okay? So for your smart contract to be real time, it needs to have some external input. This external input comes through the component known as oracle, okay? So when it comes to blockchain and AI, I want you all, given the time, I want you all to focus on this oracle component, right? So if I pull the data from an external website, can I trust the website? That is a question. So whenever an oracle is pulled out externally from the internet, it has to be verified through the consensus protocol before adding it to the blockchain. Now imagine with AI, if my oracle is an AI-based oracle, okay, I get inputs from AI to make my smart contract intelligent. That is one of the most important aspect in terms of blockchain AI integration, right? When writing your smart contracts, you take in the input from a AI additionally to support or to speed up your transaction, okay? So what happens here is on-chain. What you get offline from an oracle is off-chain. What happens on-chain may not be scalable because of the memory, right? So if you want to have a scalable transaction, you will need an off-chain transaction through an oracle, and that will help you scale your application. And if it is an AI-based oracle, that will also accommodate the various inferences from different websites, not just a single external website, right? So this oracle is where the AI integrates with the blockchain. That's one of the key features that the R&D is moving towards in terms of blockchain and AI, right? So if there is time, we could have done this, but we can always do this outside the workshop. If you want access to the slides, feel free to email me. So I have a document that I can share with you, wherein you can go to this powerful tool, which is the Remix IDE. Okay, it's an online smart contract development tool. And then there are some sample smart contracts already. You don't have to write a smart contract. There are some sample smart contracts available already. You can try to execute them. You can try to compile them and deploy them using the testnet. Okay, there are two terms, testnet and mainnet. Mainnet is a main Ethereum network. Testnet is a sample pre-deployment. You can test it using the testnet. Okay, so you can try to deploy the smart contract and test it out. And yes, so first you need to compile. Once you compile, when there is no error, then you can deploy the smart contract. Okay. Now, Ethereum also comes with its own AI chatbot. So if there's any errors, you can use AI chatbot to resolve the errors on the code and then try to deploy it, right? So this is the space where I was talking about the integration of AI and... Sorry, I have to skip this a bit. This is introduction to AI. So with the assumption that there is some introduction to AI, I want to cover on the most important aspect, where the blockchain, which holds the reliability, is enabled through a trusted data through the AI, right? So this is an important convergence where AI-driven smart contract can make your smart contract more powerful, more intelligent, right? So because the smart contract is a simple program, it's a static in nature, when I integrate it with the AI, it becomes more dynamic, right? So you can see that some of the natural language processing algorithms, even your OpenAI, right? OpenAI is not that great now, but there's also the Ollama. There's another model. So there are different LLM models available. There is different NLP models available that can be integrated with your smart contract to make your smart contract intelligent, right? But there is while AI enables to scale your blockchain application, there is a small problem with AI because AI has a integrated knowledge across all the platforms? What if the AI learns across the different blockchain nodes of decentralization, right? So it could possibly come to a centralization, right? So you have to be very careful when using AI and blockchain together. Blockchain is decentralized, but AI could possibly centralize it, right? So you have to be very careful with it. So those are some of the limitations, which is, okay, the limitations of smart contracts is flexibility and predefined logic, which is covered by AI by making it more scalable, right? Some of the examples of AI-enhanced smart contracts, right? And I think I'll skip this question. I already got the end card, but I want to just share that AI contributes to optimizing data processing, and the potential risk of integrating AI with blockchain is a centralization risk, right? So that's all. So yeah, those are the participants of the Slido. Yeah. And that's my LinkedIn. So you can all feel free to email me if you want any access to any materials. Thank you so much.